Welcome to CW 3.1. Today we're going to review everything you know about graphing. So first, let's review a few of these basic graphs here. For f of x equals x, recall that's just a line like this. Your domain is going to be all real numbers, and your range, of course, is all real numbers. For absolute value, recall you're going to have a v like this, and your domain here, once again, all real numbers. But your range is going to be 0 to infinity. The next one, all of you should know this, that's a parabola. So let's draw a nice parabola here. Make some nice points like that. Once again, your domain is all real numbers. Your range is 0 to infinity, like that. And the radical function, the square root of x, that's going to look like this. Notice your domain is no longer all real numbers, it's 0 to infinity, just like the range. So a quick refresher on those four functions we're going to need today. So now let's actually try to graph this. It says use a graph of x squared, so what we did above here, right there, to graph that. And to make it harder, let's insert a -2 here. So -2, x plus 1 squared minus 3. The first thing we're going to do is insert the parent graph. And I'm just going to do this to show you how it's important just to understand what's happening here. So right there, there's our parent graph. And what we're going to do is transform the parent graph. So recall from your last algebra class, the order of transformations the first thing you want to do is going to be stretch or reflect. The last thing you do is you're going to move, or you can call that translate. But essentially that's just movement. So for this graph, let's list out the transformations here. The first thing that'll happen is we're going to say reflect over the x-axis, and then we're going to say y times 2, or a stretch times 2, then left 1, and finally down 3. So to make it easier, let's just do the reflection first. So I'm just going to put my points here, nice reflection. And you can imagine that's a parabola going down. Now take all the y coordinates, multiply them by 2. So this first point, 0, 0, clearly nothing should happen. But this one, 1, -1, that's going to become 1, -2. And then this point, -1, -1, it's -1, -2. And let's just get rid of those. And now I can see that the parabola is skinnier by a factor of 2. Now that's why the iPad's great, because we can just grab it, move it left 1, down 3. And there is our final answer. Now in case you're wondering how I knew to reflect over the x-axis, I can do a quick refresher for you on reflection rules here. If you see the negative on the outside, like negative f of x, that means you're going to negate y. So effectively, you're going to reflect over x. Versus, if you see the negative on the inside, f of negative x, that means you're going to negate all the x values. And if you negate the x values, that means you're going to reflect over the y-axis. That's a quick tip for reflection. So now, let me move this over here. We're going to graph something a little more advanced, this thing. So looking at this, I can see that the parent is the root of x, so I can make a note of that. But notice how this is much more complex. We have this 1 minus x situation as a 2 in the front, minus 3. So the first thing you want to do is actually rewrite it. You want this to look like this. Factor the negative and write x minus 1 minus 3. Think of that as like the standard form for these, because now we can actually see what's happening. Now I can see that I can reflect over the y-axis. That's what that negative on the inside is. That's what we talked about. Reflect over y-axis. And then we're going to stretch y by 2. And then we're going to move right 1. And finally, we're going to go down 3. So I'll start with my parent. So those are my parent points we had at the beginning of the lesson. And let's just reflect it over the y-axis. So that's going to look like this. Oh, 1, here, here, and here. That's a reflection graph. Now it's stretch y by 2, so 0, 0 doesn't move. This is going to become negative 1, 2. And this would become negative 4, 4. And now once we're in the movement stage, we can just use our iPad tool to move the graph. So let's just grab this thing. And we'll just move it right 1, down 3. So 1, 1, 2, 3. And let's just put that new red dot right there. I'll get rid of that one. And there's our graph. And just to be clear, we'll label it. Let's label that point. Our new point here is 1, negative 3, and that's 0, negative 1. And that's negative 3, 1. Okay, now here's our final example. So this one, it's kind of confusing on what to do. Essentially, we're using this parent. So this is the parent for these here. I kind of had to squeeze on the paper, so I apologize for the confusion if it's kind of messy. So here's our original parent graph. We're going to take these points and basically do what we're asked to do here. F of 2x, what that's going to mean is we're going to stretch the x values. Now, in case you forgot how this works, let's put another addendum here. I'll put it right down here. Stretching rules. So this should be familiar from your Algebra 2 class as well. If you have f of a times x, that means x times 1 over a versus a times f of x is going to mean y times a. So to do f of 2x, we're going to think of this as x times 1 over 2. So essentially, the graph is going to compress. And if you think about it, it just means the graph will complete 2 times faster. So start with this first point, 0, 0. We'll do A in red. Instead of 4, 0, it's going to be 2, 0. Instead of 2, negative 2, it's going to be 1, negative 2. Instead of negative 4, 0, it's negative 2, 0. And negative 2, 4 becomes negative 1, 4. So notice how it compressed by a factor of 2. And that's because the graph is going twice as fast. So it's kind of counterintuitive here. So for B, 1/2 x is going to mean x times 2. So I know you want to see 1/2 and think x times 1/2. What happens is the graph now takes longer to complete, so the graph actually elongates. So 0, 0, of course, will remain the same. But 4, 0 will become 8, 0, like all the way out here. 2, negative 2 become 4, negative 2. And then we have negative 4, 0. It can be negative 8, 0. Let's say that's around here. And then negative 2, 4 becomes negative 4, 4. So notice how this one is going to elongate the graph. Now the last ones to do are these, the absolute value. So C is pretty intuitive. Essentially, if you ever see a negative part of the graph, you just make it positive. So for this one, let's do this in orange. The left side, nothing really happens because that part of the graph is positive. So the absolute value will do nothing. if your graph is positive. But if your graph is negative, the absolute value will make it positive. So we just flip it. And look how easy that was. Not too bad. Now D is the weird one. D, I'll do that in black. Notice the absolute values on the inside. So that's kind of tricky. So what that's going to mean is if x is positive, it's the same, right? Because you plug in f of 1, f of 2, f of 3, nothing should change because those are already positive. So these are all positive values. So I'm going to plug in my first part. That's going to be here. The x values here are all positive, which means this graph, or this part of the graph, should remain unchanged. The part that gets weird is the negative portion. So let's say I wanted to figure out the absolute value of negative 2. Right, so f of absolute value of negative 2. So our point is going to be negative 2 comma something. But the absolute value of negative 2 is 2. And f of 2 is actually negative 2. Which means our point is actually negative 2, negative 2. That's pretty weird. So it's actually right here. And then let's try another one. Let's try f of the absolute value of negative 4, which means we're plugging in negative 4. That becomes f of 4, and f of 4 is 0, which means the point is negative 4 is 0. So look what happened. That's kind of weird. It actually erased this portion of the graph and copied it with this portion. So if you think about it, I'll put a little note here. What happens is it overwrites the left side with the right side. So that's an unusual one. Okay, so that's it. So good luck on the rest of the problems, and ask me questions if you have any.